you have 4 different colors, like a black pen, a red pen, a blue pen, and a pencil would be 4 different colors, then create a legend. I'm using blue, green, red, and black, but you can create your legend whatever colors you like, and write down what your colors stand for. So what we're going to do is we're going to slowly develop everything on the unit circle. We're going to use some of our big ideas, like for the coordinates. We know coordinates on the unit circle are cos theta comma sine theta. That was one of our big ideas. Another big idea is we know that tangent is sine divided by cos. So we're going to start with degrees because that's what you're most familiar with. And if you do the axes family, that will include this point, this point, this point, and this point, because they're all 4 of those points are on the different axes. And starting with degrees, if you were at this first point, would you agree that that would either be at 0 degrees, or if you went all the way around, you could also say that that's 360 degrees? And at this point at the top, you would have, in standard position, gone 90 degrees. This point over here, in standard position, that would be 180 degrees. And the one at the bottom, 270 degrees. Now we look at those same angles in radians. Now 0 is 0 radians, but also 360 all the way around is 2 pi. 180 degrees is pi. If you know 180 degrees is pi, 90 degrees is half of pi in radians. And then if 90 degrees is 1 pi over 2, you could count 1 pi over 2, 2 pi over 2, 3 pi over 2 to figure out that angle. So now we have all those same angles in radians. This is the unit circle, so the radius is 1. If the radius is 1, you know the coordinates of this point. Because you would have gone 1 to the right, so your x value would be 1. You're on the x-axis, so your y value would be 0. Does it make sense that this point, your x value would be 0? You went up 1 unit, your y value would be 1. And we've got negative 1 comma 0 and 0, negative 1. For tangent, we're going to write the angle. So tan of 0 is equal to what? We have to use our big ideas to figure this out. Tangent is sine divided by cos. Your points on your unit circle are cos comma sine. So my sine value is 0. My cos value is 1. If I do 0 divided by 1, tan of 0 will be 0. When I get up to the top, when I try to do tan of pi over 2, my sine value is 1. My cos value is 0. What happens when you do 1 divided by 0? You get an error. This is undefined. It's not possible. Tan of 90 does not work. If you're in radians, tan of pi over 2 does not work. You can check it on your calculator. Your calculator will give you an error. When I get to pi, or 180 degrees, I would get 0 over negative 1, which would still be 0. And down at the bottom, 3 pi over 2. For the same reason that 90 degrees is undefined, tan of 3 pi over 2 is undefined as well. So just because we know the radius of the unit circle, we can label the points. And because we have the big idea that points on the unit circle are cos, comma, sine, we now open up a bunch of mental math possibilities. I can now ask a question. Kareem, you're going to pick the first volunteer. Okay? I'm going to say, what is sine of pi over 2? And you get to pick the first volunteer. Yeah. Sine of pi over 2. Okay, Josh. No, sine of pi over 2. What's it equal to without your calculator? Well, we got our big idea. The coordinates on your unit circle are cos, comma, sine. So sine is going to be a y coordinate. But where's pi over 2? Which coordinate are you going to look at? The one at the top, right? So sine of pi over 2 is equal to 1. Perfect. If I asked for cos of 3 pi over 2, Josh, you got to pick someone. Cos of 3 pi over 2, it's going to be your x coordinate down here. It's going to be 0. Okay? Then if I say tan of 2 pi, Braden, pick a volunteer. Aaliyah, tan of 2 pi. Okay, so we go to tan. Okay, 2 pi is here, this point right here. Tan is sine over cos, 0 over 1, which will be 0. So tan of 0 is 0. Tan of 2 pi would be 0 as well. If things are coterminal, they're going to have the same value. So just by drawing stuff that we already knew, we now open a bunch of mental math questions that we can do. The next family we look at, the 45-degree family. So again, now in the 45-degree family, all of the angles have a reference angle of 45 degrees. So in quadrant 1, it's going to be 45 degrees. What will the angle be in quadrant 2? 135. In quadrant 3, 225, 180 plus 45. And then in quadrant 4, 360 minus 45, 315 degrees. So all 4 of those angles have a reference angle of 45 degrees. In radians, 45 degrees is pi over 4. If you want to find the same angle in quadrant 2, that same reference angle, well, in degrees you went 180 minus 45 degrees. In radians you would have to do pi minus pi over 4. And you're going to have to ask yourself, how do I subtract fractions? What do I need to subtract fractions? I need a common denominator. How do I get a common denominator between pi and pi over 4? Well, I would make this is over 1, so I'd make it 4 pi over 4 minus 1 pi over 4. Does it make sense that this angle will be 3 pi over 4? In quadrant 3, you would have to do pi plus your reference angle. Again, you would need a common denominator, right? And you would get 5 pi over 4. And in quadrant 4, you would do 2 pi minus your reference angle. Getting a common denominator, would you agree that 2 pi is the same as 8 pi over 4? And if you subtracted pi over 4, you would get 7 pi over 4. Couple of things to notice. Okay? So I figured out all of those angles using my reference angle and which quadrant it's in. Okay. Can you see that pi over 4, or 45 degrees, splits this equally into 4 sections? This would be 1 pi over 4. The top would be 2 pi over 4. Do you agree this would be 3 pi over 4? 4 pi over 4, 5 pi over 4, 6, 7 pi over 4. So you could just count them. Makes sense as well to figure them out. Here is the nice thing about radians. It's really easy to tell the reference angle when you're talking about radians. 7 pi over 4, the reference angle is pi over 4. Really quick and easy to see that the reference angle is pi over 4. 101 pi over 4, the reference angle is pi over 4. It's really easy to see a reference angle in radians. In degrees, it's not as easy to see, quickly. 315 degrees, oh, it's 45. Is that easy to see it's 45 right away? No. So our reference angles in radians are going to be much quicker and easier to work with. Now, in order to find out the points on the unit circle here, we have to look at a special triangle. So you have some space on the right. On the space on the right, I want you to write special triangle for 45 degrees, or pi over 4. Now, if our points on the unit circle are sine and cos, then in order to find out what sine of theta is, we're going to need a right angle triangle, because sine of theta is opposite over hypotenuse. That's going back to grade 10, SOHCAHTOA trigonometry. So I'm going to draw a triangle with a right angle, because that's where I use SOHCAHTOA, and one of the angles to be 45 degrees. What's the other angle? Also 45 degrees. And if we draw a triangle with two angles that are 45 degrees, this is a special kind of right triangle. It's a right triangle with two sides the same, makes it an isosceles. What does that tell us about these two sides? They're also equal. If you have a triangle with two sides that are equal, what we could do now is we could pick any value we want for this side. Okay, I'm going to pick 1. It would work if you pick 2. It would work if you pick 3. If this side is 1, then this side is 1. And if this side is 1 and that side is 1, how do I figure out the other side? A squared plus b squared equals c squared. 1 squared plus 1 squared will be 2. This side would be the square root of 2. And so I was able to draw a triangle with 45 degrees, label sides, and I now know from this triangle, without a calculator, what sine of 45 degrees is. Sine is opposite over hypotenuse. I take my 45 degrees, I look, opposite side is 1. Hypotenuse is root 2. You can leave your answer like this, but we are going to rationalize the denominator. And write it as root 2 over 2. Similarly, could you see that you could use the same triangle to figure out what cos of 45 degrees is? Adjacent over hypotenuse. It's also going to be 1 over root 2, so I'm also going to write this as root 2 over 2. And from this triangle, can you see what tan of 45 degrees is? Opposite over adjacent, 1 over 1 will be 1. So from that special triangle, we can now label our coordinates. Our coordinates on the unit circle are cos comma sine. At 45 degrees, cos is root 2 over 2. Sine is root 2 over 2. In quadrant 2, do you notice it's the same triangle? So cos will be root 2 over 2 again, And sine will be root 2 over 2. But now, since you're in quadrant 2, I'll make that even more obvious, that negative, that your x coordinate will be negative. And in quadrant 3, can you see both your x and your y coordinates would be negative? And finally, in quadrant 4, your x coordinate is positive and your y coordinate is negative. Once again, we can also add tan to each of these. Tan is sine over cos. We've also got it from our triangle. So tan of pi over 4 is equal to 1. Can you see if you did the sine divided by cos, root 2 over 2 divided by root 2 over 2, you'd get 1. But you can also really easily get it from the triangle, right? Because tan is opposite over adjacent. And then in quadrant 2, tan of 3 pi over 4, well, it'll be equal to negative 1 this time because the cast rule says tan is negative in quadrant 2. And if you did sine divided by cos, one of them's positive, one of them's negative, you're going to get a negative answer in quadrant 2. In quadrant 3, tan of 5 pi over 4, it's going to be positive 1. Cast rule says tan is positive in quadrant 3. But if I do sine divided by cos, I have a negative divided by a negative, which is positive. And finally, tan of 7 pi over 4 will be negative 1 as well. Who is our last volunteer? Aaliyah, you get to pick the next volunteer. Okay, pick. And we want to figure out what cos of 135 degrees is. Carson. All right. What is cos of 135 degrees? Close. You're in quadrant 2, right?
Oh, so negative 1 over square root of 2.
Negative 1 over square root of 2 or negative root 2 over 2. Both of those would be fine. Okay. Next one. Sine of 7 pi over 4. Pick a volunteer.
Spencer.
Spencer. Negative square root 2 over 2. So you see how that big idea really comes into play here. From the picture of the unit circle, if you know where you're at and you can look at the coordinates, you can find sine and cos right away. Okay, if I asked tan of 5 pi over 4, well, that one's just listed. So you'd be able to say 1. But I could say also tan of 225 degrees would also be equal to 1 because it's the same angle just in degrees. So this is our second family. The pi over 6 family. So again, we'll start with degrees. 30 degrees here. And I'm going to give you guys 10-second head start to do the rest of the degrees. How did you do? 210, 150, 330. Now in radians. Pi over 6 there. I will give you a minute head start on the radians. All right, let's see how we did. Did you get 5 pi over 6 here? Again, you could do pi minus pi over 6, 6 pi over 6 minus 1 pi over 6. Here, 6 pi over 6 plus 1 pi over 6 gives you 7 pi over 6. And this one, 12 pi over 6 minus 1 pi over 6, 11 pi over 6. Now, once again, we're going to draw, and you have space right here. We're going to draw a special triangle for 30 degrees. I'm going to make a 90-degree triangle. I'm going to label 30 degrees. And what would the other angle be? 60 degrees. And since our next family is the 60-degree family, it's actually the special triangle for 30 degrees and 60 degrees. Now, last time when we made our 45-degree angled triangle, everything worked out nice, that we noticed it was isosceles and it was special, so we could label two sides as one and figure out the other side. This is a right angle triangle with 3 different sides and 3 different angles. What's the name of a triangle with 3 different sides and 3 different angles? Do you remember that name? No, nobody remembers the name. Because it's really, of all the triangles, it's like the you're not special triangle. And so the you're not special triangle got a special name, probably just to make them not feel so bad. This is a scalene triangle. Remember that word? It's like, no. Because you're like, you're not important, you have no special properties, there's nothing important about you, so even though you have a name, I forget you. This is a scalene triangle. So this scalene triangle is feeling a little bit bad about himself. Like, I'm not special, not happy at all. And so we really can't say anything about the sides. So scalene triangle's really sad, looking around, runs into another scalene triangle. They look the same. They're identical, and they're like, hi, and they're, hi, are you special? No. Are you special? No. Oh, okay. So they were like, well, since we're both not special, you want to be friends? And they said, okay. So a second scalene triangle with 60 degrees, 30 degrees, and 90 degrees comes along, and they become friends, and they come together. And when they're together, they become special. What's nice about this triangle when I put them together? It makes an equilateral. And what do we know about equilateral triangles? All the sides are the same. So I could pick any random number. I'm going to choose 2. I'm going to make this side 2, this side 2, which would make the bottom 2. But since the bottom is split nicely into 2 equal sections, would you agree this would be 1 and this would be 1? And now we have enough to do a squared plus b squared equals c squared. 2 squared minus 1 squared is 3. Would you agree that this side here would be the square root of 3? You could check it. A squared plus b squared equals c squared. 1 squared is 1. Root 3 squared would be 3. 1 plus 3 is 4. Square root of 4 is 2. Yeah, I did c squared minus b squared to find the root 3. And then when I checked it, I did it a squared plus b squared equals c squared. And now that we have those sides labeled, well, we can figure out sine of 30 degrees, cos of 30 degrees, and tan of 30 degrees from our triangle. Sine, 30 degrees, opposite over hypotenuse, 1/2. Cos of 30 degrees, adjacent over hypotenuse, root 3 over 2. Tan of 30 degrees, opposite over adjacent, 1 over root 3. And just like we did before, I'm going to rationalize to make it root 3 over 3. Since we've drawn it already, our next family is 60 degrees. I'm going to figure out sine of 60 degrees, cos of 60 degrees, and tan of 60 degrees from that same triangle. Sine of 60, opposite over hypotenuse, cos of 60, adjacent over hypotenuse, and tan of 60, root 3 over 1, which we're just going to write as root 3. So we can now go back and label our coordinates. Our x-coordinate is cos. Cos of 30 degrees, root 3 over 2. Sine of 30 degrees, 1/2. In quadrant 2, the x-coordinate would be negative, the y-coordinate would be positive. In quadrant 3, they would both, the x and the y-coordinate, be negative. And in quadrant 4, the x-coordinate would be positive and the y-coordinate would be negative. From our special triangle, we know that tan of pi over 6, or tan of 30 degrees, is root 3 over 3. And now we can figure out all these ones as well. They just change positive and negative due to the cast rule and due to the fact that tan is sine divided by cos. Who's our last volunteer? Spencer? Pick a new volunteer. I want to know what cos of 7 pi over 6 is. Cos of 7 pi over 6. Yes, it'll be your x-coordinate, negative square root of 3 over 2. We will go tan of 330 degrees. Pick a volunteer. Who are you going to pick? Who hasn't gone? Tristan hasn't gone. Christian hasn't gone. Liam hasn't gone. Caden hasn't gone. Brett, have you gone? No, Brett hasn't gone. So pick a volunteer. Brett. Negative square root 3 on 3. So 330 degrees is the same as 11 pi over 6 radians, and so it'll be negative square root 3 on 3. All right, last family, the 60-degree family, starting in degrees. 30-second head start for you. How did we do? 120 degrees, 240 degrees, and 300 degrees. Radians, pi over 3. A minute head start. Did you get 2 pi over 3, 4 pi over 3, and 5 pi over 3? One minute head start to do your coordinates. All right, check how you did. You get 1/2 root 3 over 2. Negative 1/2 root 3 over 2. Negative 1/2 negative root 3 over 2. And finally, positive 1/2 negative root 3 over 2. Finally, tan of pi over 3 is root 3. Tan of 2 pi over 3, negative root 3. Tan of 4 pi over 3, root 3. And tan of 5 pi over 3, negative root 3. next thing we're going to do is we're going to take all of this information from all 4 families and combine it onto a single sheet of paper. Okay? And this single piece of paper, it says the Unit Circle quiz on the top because it is the only quiz that I give you before your quiz, and you know exactly what it's going to look like. So this is your quiz with all of these blanks, and you will have to fill in all of the blanks when we have our quiz. The only thing different about this quiz compared to other quizzes is there are only 2 possible marks. You will either get 0 or 100%. Out of 10 points. Either 0 out of 10 or 10 out of 10. The other thing that's different about this quiz is that you do it until you get it 100% right within a week. If you can't get it within a week, then you get 0. But you get as many chances as you can within the week. Most people get it right. I will say most people will get it right on the first try. But there's a lot of information there. But there are a lot of patterns to make it easy. So that's one of the things you're going to try to figure out, how to make it easy. One of the things that I've done here on this one is I color-coded my families that go together. Because if we look at, say, the 60-degree family, can you see if you know the coordinates in quadrant 1, you're going to be good for the coordinates in all the other quadrants. And so, same thing, there's patterns with the radians, there's patterns in the family with the degrees. Yeah, if you know the first quadrant, you're going to figure out all the other quadrants. And then there's even tricks to figuring out the first quadrant. So I'm going to hand out the quiz. And I would suggest there's 2 sides. So there's one side for you to fill in all the information, and the other side is for you to practice once you think you're ready. No, this is just for you. But when this is the quiz. When I hand out the quiz, when we're going to do the quiz next week, haven't put it up here yet. It'll look exactly like this. No, it's not open book. You have to have it memorized. Worth a try, though, right? Okay. We're going to do it next week, Tuesday. So that'll give you a weekend. It'll give you the weekend to study. Right? That's what it looks like when it's all filled out. Okay, there you go. And you have to do the chart at the bottom as well.